In this lesson, we're going to be talking about the epsilon-delta definition of the limit. The way this reads is, this reads for all epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus c is greater than 0 and less than delta, then the absolute value of f of x minus L is less than epsilon. So instead of having to rewrite this every time, we just write it like this. The limit of f of x as x approaches c is equal to L. And this means all of this up here. Now L is a real number. And f of x, of course, is a function. I've got a graph drawn out here to get an idea of what we're talking about. So the x minus c, the absolute value of x minus c is greater than delta, or I'm sorry, is less than delta and greater than 0. Okay, when we unravel that, this is what we get. We get c plus delta. In other words, x is less than c plus delta, and x is greater than c minus delta. This is the same thing when you unravel this piece here. You drop the absolute value bars and solve basically for f of x. You get f of x is going to be less than, you bring the L over, L plus epsilon, and greater than, f of x will be greater than L minus epsilon. Now, this may seem kind of abstract for most, but you'll get the hang of it after maybe working some examples. The idea here is we want to construct a delta, and we end up constructing a delta, a largest such delta. There's an infinite number of deltas, but we want to pick the largest such delta inside of this interval here. Now you noticed, if you can tell here, that this interval here is smaller than the interval between the difference between c minus delta and c plus delta. So when we choose a delta, it needs to be it's going to have to be it needs to be the largest such delta. But if I chose, for example, this red delta, the red delta here, then this interval here, that means that I could go over in this direction, okay, c plus the red delta, but as you can see here, I am outside. If I go straight up to the graph, I am completely outside of the interval. My f of x has to stay between L plus epsilon and L minus epsilon. It has to stay in here. So we can't choose this delta, and because look at the distance here, okay, this distance here is so much bigger. If I choose this delta here, then as far over as I can come is here, and therefore x value would have to be inside of this piece here. I hope I'm making this clear, maybe. But the difficult thing is constructing this delta. I'm going to be giving an example, and what we're going to do here is we're just going to choose an epsilon. Now, back up here in our definition, this is for every epsilon greater than 0, but we're just going to nail one epsilon down in the first example of trying to understand this concept, and I think I'm going to let this epsilon end up being 0.1. So you want to check that lesson out so we can get an example here of what we're talking about.